In this lesson, we're going to look at 3 new theorems that deal with proportionality. So if we look at this very first theorem, it says that if a line parallel to one side of a triangle intersects the other two sides, then it divides the other two sides proportionally. So if you have a line that is parallel and it intersects two other sides of a triangle, so it's parallel to one side and it intersects the other two, then that means that it's dividing the other two sides proportionally. So this is sometimes referred to as the Side-Splitter Theorem. But really what happens is we can set up a couple different proportions. I can say TR over QT is in the same ratio as UR to SU. So that's one way you could set this up. So the parts here are going to be all in the same ratio. Another way would be if you compare the parts here. So if I compare QT, I can compare that to SU. That ratio is going to be the same as TR to UR. So either way would work for what this theorem is saying. So looking at an example using this theorem, again, the first thing you have to know is that these sides are parallel, so that this segment is parallel to the opposite side. So those arrows indicate parallel. So since that's true, I can set up proportions. I can say, if I kind of follow this format first, I could say 6 to 2 is equivalent to 9 to x. So that's one option. You could also say 2 to x, x is equal to 6 to 9. So that's another option for the setup. The other thing too, keep in mind, you could flip these. It doesn't really matter what you start with. So you could say, I'm going to start with 2, compare that to 6. So then that would mean x would compare to 9. So lots of options for setting these up. So either way, what ends up happening here when you cross multiply, so let's just say I pick one of these to cross multiply, I get 6x equals 18. Notice same thing over here. That's why in the end you end up with the same equation. So divide by 6, you get x equals 3. And it just says solve for x, so that's all I'm doing. The next theorem says that if you have a ray that's bisecting an angle, so meaning you have an angle bisector, so if we have an angle bisector, it's going to divide the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So that means that this piece that's getting divided, that segment that's getting divided, it's going to be proportional to these pieces here. So when I go to look at the way I can write my proportion, we could say AD over DB is the same thing as saying AC over BC. Another option for this would be to compare the part to the side. So I could say the part over the side, and then DB over that side. So lots of options. So if I go and use this to solve, I know that this is an angle bisector, so it does have to be an angle bisector, so you have to be told it's an angle bisector, you have to see the congruent parts, and then you can apply your proportion. So the angle bisector theorem, so I can say 3.5. So if I kind of do it how I did here, so I compared the parts first, so I could say the 3.5 over the x is equal to the 5 over 12. Another option would be compare the part to the side of the triangle. So I can compare the 3.5 to the 5 equals x to 12. So either way, when I cross multiply these, you're seeing the same numbers in the diagonals. So in the end, when you cross multiply, you're going to have 5x equals 42. And then go ahead and divide by 5, and you end up with 8.4. And again, solve for x, so that's it. I don't have to go any further. So again, just another way that you can set up proportions. So lots of proportions happening in this unit. So these are just some additional ways that we can set up proportions. The last one doesn't occur as often because in this unit especially, it doesn't really, it's possible to have triangles formed out of it that are similar. But when I look at just this picture, this is kind of going back to one of our units at the beginning of the year when we saw parallel lines and different transversals being involved. But it is good to bring this up because it is a proportionality theorem. So what you have to have for this one is if three parallel lines intersect two transversals, then they divide the transversals proportionally. So you have to have your three parallel lines. So again, these lines are the parallel lines because they have the arrows on them. And then I have to have the two transversals. And what happens is these parts here are going to all be in the same ratio. So one setup would be to say UW over VX is equal to WY over XZ. That's one option. So kind of comparing the different, like this, comparing using the same parts. Or you could compare using the, on the same transversal. So meaning I could say UW, compare that to this small part. And then VX compares to this small part here. So that's another option. So again, same idea as the other ones, different ways that you could set these up depending on if you're going from, if you're looking at the corresponding parts when you set up your ratio, or if you're using the same figure and comparing the two parts in the same figure. So when we go to set this up, same idea, you can use the corresponding parts, how I did this first. So I have 8 to 10 is equal to 6 over x, so looking at the corresponding parts. Or you could look at the two different parts in the same, on the same transversal. So I could say 8 to 6 is equal to 10 over x. So again, when you go to cross multiply, you're seeing that the numbers and the diagonals are the same, meaning you would have the same result when you cross multiply. So it's going to be 8x equals 60. Divide by 8, and you end up with 7.5, or you could say 15 over 2. So there's my value for x. So go ahead and get your key ideas down. Really, you have 3 different theorems that you should know. And then go ahead and try the check your understanding problems, and we will talk about those tomorrow.